Hey guys, how's it going? Welcome back. And today we will hack Jakarta-RS. In particular, we will go into a new feature. I contributed a new method to Jakarta-RS 4.0, which is upcoming next year. And this new method you will love if you write a lot of generic JAX-RS filters. So stay tuned for this trick. To better understand why you would love this method when writing filters, let's look into a filter that we have in the JAX-RS example folders. And it's really not a good filter that's ready for production. It's only an example how to write filters, okay? So just ignore the code that the filter actually implements. This is not production code. The interesting point with this filter is what is this good for? And this filter actually applies caching. So it looks up whether there is a cached response already stored, ready to use. And if it finds one, then it will use it instead of going on in the processing chain. So if you would write code like this, then you typically would filter always, and this is not good because there is an RFC that says you should not apply caches when the client does not want that. So the client can ask you to not cache at all, and this code is not checking that. So typically what you would do now is that you would like to check if we may cache at all. So if we must not cache, then we simply return. So the question is, how can we find out whether we may cache or not? There is an HTTP header that tells us whether a cached response actually is allowed or not. Actually, there are a lot of cache control values, and since this is not about caching or doing caching correctly, this is only about a new method. I'm really sorry that I maybe picked the wrong one now, but I just want to explain you what the problem is. So the problem is you can have cache control, typo, no store like this, which means don't store into a cache or pull it from the server without looking into caches. Or you can have cache control like this, which is a simple upper lowercase problem. Or you can have cache control like this, max h, and like this one, for example. Sorry, this must be a comma. Or you could have it cache control max h 0, no cache, no store, and so on. And you even could have any combination of that, because it's pretty valid to have cache control multiple times. So looking into the existing methods, what could we do to check these lots of headers and header values in a correct way? Well, the first thing that comes into mind is, where is it? Get header string for cache control, for example. So what does this method do? This method will return a string which is comma separated. So this will return a string like no store. If we would have all the headers set from above, so you get an idea what the result is. So to produce this string, the computer actually has to walk through all these headers and concatenate them, which needs time, not much time, but it needs time. And on the other hand, we now have to tokenize it, which you can do with split, for example. Well, the problem with the splitting is it also needs time, and it might be wrong because cache control is separated internally with commas, which is fine, but there may be custom headers. For example, my custom header, which has a comma inside, and this might be something different than the combination of this. Let me do it. Well, sorry. Come on. So while we would think concatenation by comma is correct here, it might not be correct for all the cases. For example, my custom header might do something different when having this one compared to having 3 separate headers. So it's not always that easy. You cannot always rely on the split of the string. So what can we do then? We could iterate. So for example, we could check all the single strings like get header, and then we can walk through it somehow, checking the name, checking the content, and separating in a different way. Well, there's another problem with that, because now we walk through all the headers, and maybe there are lots of them, so this also produces a lot of computation that we want to prevent. And well, actually it also is not nice. It's just like a lot of handling crap. We want to get rid of that. Also, there might be blanks and white spaces like this, for example, so we have to trim it, and the code just get clumsy when we do this every time in every filter. So let's use our new method instead, which is this one. You now can ask the implementation of JAX-RS, like Jersey, for example. Hey Jersey, do you know whether we make cache? And we can do it like this one. We give it the header name. Let's do it in lower cases, as this is typical meanwhile. And here we have to give a predicate, and the predicate tells us what must be true for each of these, for the standalone ones, just as the single values in this separation lists. And in our case, we would say no store equals ignore case. What does this mean? So this method forwards the request, what we want to check, to the implementation, and it says check if you have one or more cache control headers. So this is a fast access because it uses the hash table of the strings, which is much faster than iterating them. And then it applies this predicate, which means, is there a no store single value like this one or this one? Or is there a no store value, value in a list? So it doesn't care about this one. And it does apply equals ignore case. So this one is just as good as that one. And its Java doc says it even trims. So it doesn't care about this one or that one. So it still will find this one. So this is what this line does. So it completely answers our question this is, if we have this one, this is the full question. Do you have a rule that says you must not cache? So this goes away. And this will handle all these cases, even the combination. And this is really nice to read. It just says, hey, request contest, do you have a header cache control that contains no store in any case? And it says, yes, I have that, so we must not apply our cached result. So this is really brilliant to read and rather easy and bug-free to write. And it provides the best performance you can think of because it does not iterate. It uses the hash table and it applies the rules exactly as you want them without splitting and concatenating and a lot of string handling and GC in the background. It really checks the existing values, and it's really the best of all worlds. On top of that, you can use different predicates. For example, you could use a predicate that not checks equals ignore case, but it's much more complex. You could even use a lambda expression here, doing something that you want. So this is really versatile. And on top of that, this variant actually implies a comma. And if you don't want to have a comma here, you can use this one, where the value separator is a regex. So you could even go with very complex cases with groups in it and with repetition rules and all that. So this is really, really great. It's simple, it's easy, it's fast. It's the optimum way to implement your filter checks. And this is why you love this method. So far for today, hope you liked the video, and if you did, give me a bold thumbs up, subscribe to my channel, press the bell so you don't miss any new videos, and as always, stay safe and party on.